suppose you got a new job, and I'm your boss. And you draw a slip of paper from a bag to determine your wage for the day. The random variable X is your daily wage per hour. So notice your options. You can get $1 an hour. You could get $25 an hour. But you got to draw it out of a bag each day.
You probably didn't put any 25 like that.
I what?
You probably wouldn't put any 25 in the bag.
No, bro. There's one of them. Look. There's one. There's 30 slips of paper because I have 30 employees. So there's one of them will get a 25. Right? What's your... So the first thing it's asking us to do is calculate and interpret the expected value of X. What does that even mean? Do you remember that from yesterday? Yeah, it means find the mean of X, the mean of these values. Does that mean I'm literally just adding them up and dividing by 6? No, right? It's not, because that does not take into consideration the probabilities that are given, right? That would give each wage equal weight. That's what I'm trying to say. And that's not what the probabilities are saying, is it? So we have to do it using that formula. Remember, the formula looks like this. It's sigma xi times pi. What the heck does that mean in math? Like with this example, xi is the outcome, so I do 1 times 3 out of 30 plus 2 times, or not 2, the outcome's 5, my bad. 5 times 6 out of 30 plus 7 out of 7 out of 30 plus 10 times 10 out of 30 plus 15 times 3, plus 25, 1 out of 30. All right, and that's a beating to put in your calculators, right? I'm going to show you how to do that right now in your calculators to save you all the grief. So pull your calculators out with me. As I split my screen. Okay, so what we're going to do is use our lists, stat edit, and we're going to put the outcomes in list 1, and we're going to put the probabilities in list 2. So if I go to stat edit, I got junk in my list. If you do like me, then just go up to the name of the list, L1, L whatever, hit clear and enter, and that should empty it. So L1, I'm going to put my outcomes. So it's 1, 5, 7, 10, 15, and 25. Those are the wage possibilities, right? And over here in list 2, I'm going to put the corresponding probabilities. Now, don't let the fraction freak you out. Watch what happens. I'm going to put it in just like it looks. 3 divided by 30. Boom. It makes the decimal for me. Oops. All right, got them in there? Once you have all that in there, then you're going to go back out to, you're going to go to Stat, Calc, and we're going to use 1var statistics again. And list, you want under list, you want it to be L1. And frequency, this is different than before. You want this to be L2. Because we want it, and the way to get to L2 is just to hit second and number 2. And then hit enter. Boom, there's your answers. Now, X bar stands for mean, doesn't it? So guess what? All this work, if I put it in the calculator, would come up as 8.4. It's doing all that math for me. All right, that is your shortcut to it. So when you're doing this, when you're writing your questions, as far as work, what you would want to do, I know the calculator is going to do the mathing for you, but what you would do is like write the first couple plus this, and then you would do dot, 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 plus that last term and hit equal whatever you have. You don't have to write every single term. Does that make sense? But you kind of show the formula worked out a little bit, and then let the calculator calculate it. All right. Now we need to interpret. It's your favorite part, right? Do you remember how we interpret? So what are we doing? What are we drawing here? What do these X values represent? Wages. So if I start to interpret this, I would say, if we take many, yes, too many's wages. Got to take a bunch because then you can average them. Can't just average one. Many wages. The average hourly wage is about $8.40, right? We're talking money here. We take many wages. The average hourly wage is about $8.40. Okie doke. All right, so now we're going way back to Unit 1. We did standard deviation. Remember, it tells us the typical distance from the mean. That's what we use when we interpret it. So complete the table to calculate the standard deviation for the probability distribution. So we can do this by hand, but you're going to hate it. I'm just going to tell you right now. Because look what you have to do. Distance from the mean. So you have to take each value. So this is 1 minus 8.4, which means it's negative 7.4. 7 minus 8.4, which what makes it negative 1.4? 1.6, and so on and so forth. Then you would have to take this distance and square it. Negative 7.4 squared. Give me 54.76. And then you have to do this. Then you have to weight it. Weight it means multiply by the probability. So watch this. We're not going to do this for everyone, but I would have to do 54.76 times the 3 out of 30, which would give me 5.476. Okay, that's the weight. The probability is the weight. Then, look at that. Then you have to add them all up and get a total and divide by the total. You're loving this, right? So great, isn't it? Nobody wants to do this formula. Even AP College Board people know it's ridiculous because we have technology that does it all for us now, right? So you're never going to have to do this table. This table is to help you appreciate that calculator and love on it and take good care of her because she's doing all this work for you. Because this standard deviation is on that display we just got where it says sigma x. That value has already been calculated. You see the sigma in there? 4.76. It's already there for you. Alrighty. Now, What do I do with that? Well, okay, you don't have to calculate it, and you usually don't even have to show work for standard deviation. It's either given to you or just straight up ask what it is, okay? But you do have to interpret. Always going to have to interpret. Alrighty? Now, of course, this formula is on your chart, but nobody ever reads that formula. But interpret the standard deviation. And we would say the wages typically vary by, what is it, 4.76? $4.75 or 76 cents from the mean of, and what was the mean? $8.40. Now your formula for standard deviation, not that you care, but it is on the chart, looks like this. It is sigma each x term minus mu squared times its probability, and then we add them up and all that business. But it's on the chart, not necessarily. What you got to focus on is making sure you are able to correctly interpret. Okay? Okay. Dobbs decides she would rather assign wages so that the employees could get any amount from $10 to $20. That means I could do $10.75, right? Or $10.79. Every decimal value between 10 and 20 now are equally likely. Draw a graph to represent this probability distribution. So, equally likely, what does that mean? Do you remember? What would that look like? All the probabilities are the same. So what would the curve look like this?
No curve.
Or would it be like that? Does that mean all the probabilities are the same under that curve?
No.
Remember when I say probability under the curve, that's talking about the area under the curve. None of those they're not all the same. So this would look like a big old rectangle, wouldn't it? That would indicate all the probabilities are the same.